Here are solutions to quiz number 5 for ECE 320. The first problem is a 555 timer. Given this circuit, come up with the values of R1 and R2, given that C is your birth date. For me, that'd be 1314 microfarads. So that the on time is 2 milliseconds and the off time is 8 milliseconds. The equations are up here. So starting with the off time, we have one unknown, solve for R2, and you get R2 times C times log of 2 is 8 milliseconds. R2 is 8.78 ohms. The second equation, make that equal to 2 milliseconds. This says R1 plus R2 is 2 ohms, which says that R1 is negative 6 ohms. What's happening is, well, the math is trying to tell you something. What the math is telling you is you can't build it with this circuit. You need a negative resistance. Essentially a charge through R1 and R2, a discharge through R2. And it's not possible for R1 plus R2 to be less than R2. So you can't do it with this circuit. It is doable though. I need a different circuit. And to do that, I simply do this. Add a diode at that point. I now charge through R1. That sets the on time. I discharge through R2. That sets the off time. But that's a different circuit, so either answer is acceptable. Negative resistance, or just simply state not possible with this circuit. Problem 2 is design a BJT switch. When this is 5 volts, I want the switch to be turned on, and the current draw is based on your birth date. For me, it's 1314 milliamps. So to do that, I have, when this is saturated, this is 0.2 volts. 12 minus 0.2 over I gives you the resistance, 8.98 ohms. The smallest that IB can be is IB has to be at least enough to saturate the transistor, at least IC over beta, at least 6.57 milliamps. This is 5 volts, this is 0.7. 4.3 volts at 6.57 milliamps is 654 ohms. That's one limit. The biggest IB can be is 25 milliamps. So solving 4.3 volts at 25 milliamps is 172 ohms. RB has to be between 172 and 654 ohms. Problem 3 is a Darlington pair. This one gets kind of tricky. If this is 1314 ohms, it depends on birth date, find the currents, assuming that the current gain HFE or beta is 200. Well, right away, I know here's the diode. Let's assume these guys are on. Here's the diode. This is 0.7 volts. This is another 0.7, 1.4 volts. And the smallest this voltage can be is 0.2, which makes this 0.9 volts. Once I get the voltages, I can find the current. I4 is 12 minus 0.9 over 8. I1 is 5 minus 1.4 over 1314. I know that I1 plus I5 is I2. This is 0.9 volts. That says that transistor is in the active region. I know that I3 is 200 times I2. Solving, you get I2 is 6.9 milliamps, and I3 is 200 times that, 1.38 amps. So that's what you should get. On to problem 4. Problem 4 is a comparator. What I want is this type of relationship, 1200 ohms. I want the output to go high. So when R is bigger than 1200 ohms, I get 5 volts. Less than 1200 ohms, I get 0 volts. Here, if you pick the resistor as your birth date, makes each test a little bit different. The trick is to find out what's the voltage at 1200 ohms. By voltage division, this is 2.3866 volts. So I want to turn on at 2.3866 volts. And when R is large, the voltage is large. When the voltage is large, I want the output to be high. Connect the plus input. So there's the circuit that turns on at 2.38 volts, or turns on when R2 is bigger than 1200 ohms. Problem 5, Schmitt trigger. In this case, what I want is the output to be 5 volts when R is less than 1200 ohms. So kind of get this at 1200 ohms, it turns on. At 1300 ohms, it turns off. So the first step is to convert resistance to voltage. Use a voltage divider using a birth date that gives two voltages. This is 2.38 volts, I turn on, and 2.48 volts, I turn off. Since the on voltage is less than the off voltage, I connect to the minus input. The on voltage is the offset, and the slope is the gain. Output changes by 5 volts as the input changes by 0.1, gives you 50-to-1 ratio. Pick these to be 50-to-1. So that's problem number 5. And the calculations. Problem number 6 is given the circuit, how does it behave? Well, I know I'm connected to the minus input. That tells you that V on is less than V off. So it looks like this. The on voltage is 3.2. The slope tells you this distance. This has a gain of 5. Output changes by 5 volts. When the input changes by 1/5 of that, 1 volt. So that means this is 4.2 volts. To find the resistance, use voltage division. I know that R2 over R2 plus R times 5 volts is 3.2 volts. Solving, doing some algebra, you wind up with R2 is 2336 ohms. In this case, when it's 4.2 volts, I get 6898 ohms. So that is quiz number 5 for ECE 320.